As promised, here are some solutions to the 4.4 task. Again, task 4.4, features of rational functions. If you have not watched the previous video explaining how to find x-intercepts, vertical asymptotes, and y-intercepts, go back and watch that first. This is just going to run you through solutions for a couple of these problems. Okay, let's dive into number 2. So I'm going to start with my x-intercepts. X-intercepts always come from the numerator, so I'm going to look at my numerator, and I'm going to set those equal to 0. X plus 6 equals 0, and x minus 3 equals 0. So I get x equals negative 6, which is the intercept of negative 6, comma 0, and x equals 3, which is the intercept of 3, comma 0. Let's double check to make sure that makes sense. Well, negative 6 is kind of hard to see, but it does make sense. That's where it would cross the x-axis. And same with 3. 3 is hard to see, but it does make sense that that's where it might cross the x-axis. So there we have our x-intercepts. Move those out of the way, and let's move on to our y-intercept. So our y-intercept is going to be found by plugging 0 into the function. So I'm going to do g of 0, meaning I'm plugging in 0 for every single x. So that's going to be 0 plus 6, 0 minus 3, divided by 0 squared, which is just 0, plus 5, 0 plus 1, and 0 minus 1. So our numerator ends up just being 6 times negative 3. Our denominator is 5 times 1 times negative 1. Or negative 18 all over negative 5, just 18 fifths. So when I think about this point, which is going to be 0, 18 fifths, I think, well, 5 goes into 18 3 times with a little bit left over, so it's going to be some number just above positive 3. And I see that right here. That is where my y-intercept is, so it matches up. Okay, so we've got our x-intercepts that came from the numerator, our y-intercept that came from plugging 0 in for every x in our function. Let's jump down to our vertical asymptotes now. Our vertical asymptotes come from the denominator, so let's set each one of those equal to 0. X squared plus 5 equals 0, x plus 1 equals 0, and x minus 1 equals 0. Okay, subtract 5 from both sides. X squared equals negative 5. Take the square root of both sides, and immediately I have an imaginary number. X equals plus or minus radical 5 I. We're not going to graph those. Imaginary numbers do not appear on the graph, so we're not going to worry about those at all. We're not going to worry about those ones. We're just going to skip past them. Then we get x equals negative 1. That is going to be one of our asymptotes. And x equals positive 1. That's also going to be one of our asymptotes. Let's check the graph. So at negative 1, I do see that our graph kind of repels away from it. It goes off to positive infinity, off to negative infinity, and I see that same pattern here at positive 1. So those match up. I have asymptotes at negative 1 and positive 1 on the x-axis. So I told you for domain, I like to think of it as a number line where my graph does go from negative infinity to positive infinity because it does kind of go off in either direction. You can see that from the graph really clearly. It goes off in either direction, left and right. But there's a hole at the first asymptote, negative 1, a hole at the second asymptote, positive 1, but every number in between works. Every number in between will be represented on our function. So that means our function is going to have negative infinity up to negative 1, a break at negative 1, negative 1 up to positive 1, a break at positive 1, and then 1 to infinity. You should be noticing that your vertical asymptotes will match your domain every single time. Okay, let's try another one. So x-intercepts. Say it to yourself out loud right now. Where do the x-intercepts come from? Pause the video. Make sure you know this before pressing play again. X-intercepts come from the numerator, guys. Numerator. So I'm going to take that numerator, x plus 2, set it equal to 0. X equals negative 2, which tells me at negative 2, comma 0, I have an x-intercept. Let's check it. Perfect. We do see that x-intercept. Okay, y-intercept. Right now, say it out loud to yourself. Pause the video. Once you know how to find the y-intercept, press play and make sure you got it right. Hopefully you said you're going to plug in 0 or do h of 0, and that's exactly what we're going to do. 0 plus 2 is our numerator. 0 plus 3, 0 minus 1 is our denominator. So that's 2 divided by 3 times negative 1, or negative 2/3. So we have the point 0, comma, negative 2/3. Let's check to make sure we did that right. Yep, we have a number just shy of negative 1. Negative 2/3 matches up perfectly. Now let's move down to those vertical asymptotes. Where are we looking for the vertical asymptotes? Test yourself right now. Test yourself right now. Hopefully you said the denominator. Hopefully said you're looking at the denominator and setting it equal to 0. X plus 3 equals 0 and x minus 1 equals 0. So we have x equals negative 3. That's going to be one of our asymptotes. And x equals positive 1. That's going to be our other asymptote. Let's check the graph. Positive 1, I see that one really clearly. That asymptote fits in. Again, it's that line that your graph gets really close to, but it never touches. You're not going to see a point on the graph for positive 1. It really is going to be a void. Same for x equals negative 3. That one does also have this line that kind of divides or breaks your graph. You're not going to see a point at negative 3. There's going to be that kind of open vertical line there. So when we're doing our domain, we're thinking, well, it is every single number from negative infinity to positive infinity, but there's this break at negative 3 and this break at positive 1. But every number up to negative 3, every number between negative 3 and 1, and every number past 1 is going to work. So that's negative infinity up to negative 3, negative 3 to 1, and 1 to infinity. So there are those first two solutions for you. Let's try some more. So let's explore number 4. X-intercepts come from where, guys? Where do those x-intercepts come from? Where do we look? The numerator. Set that equal to 0, and I just get x equals 0. So that's my point 0, 0. And if that's my x-intercept, that's also my y-intercept. Let's test it out. J of 0 is 4 times 0 over 0 plus 5, 0 plus 2. That's 0 over 5 times 2, which doesn't matter that it's actually 0 over 10. It's just 0. So yeah, that is the same. Your x-intercept and your y-intercept both are 0, 0. So let's go to our vertical asymptotes. Where are we looking for the vertical asymptotes? Say it out loud. Check with yourself right now. Make sure you know it. We're looking at the denominator, guys. I'm going to set each one equal to 0 separately. X plus 5 equals 0, and x plus 2 equals 0. So x equals negative 5 is one of our vertical asymptotes, and let's confirm that. Yeah, this one isn't as tightly grouped around negative 5, but I can see that there is no point on the graph where negative 5 is, and our graph kind of turns away from it down here in the negative direction and up here in the positive direction. Our second asymptote is going to be x equals negative 2, and let's confirm that with the graph. Yep, I don't really see a point at negative 2, and I do see my graph kind of breaking or turning away, going up in the positive direction and down in the negative direction around negative 2. So that one is also our asymptote. So when we think about our domain, once again, we know it's all of our numbers, negative infinity to positive infinity, but there is a break in our graph at negative 5. So it's all those numbers up to negative 5. There's a break in our graph at negative 2, so it's our numbers between negative 5 and negative 2, and then every number greater than negative 2. So negative infinity up to that first asymptote, in between the asymptotes, and then beyond that last asymptote. Okay, I'm gonna save the last two for you guys to try on your own. Obviously the graphs are right here, so you can check your work with the graph. Ask questions on these in class. I would love to work on them with you guys.